Hello everybody and welcome to another live stream from Learning and Technology with Frank. I'm Frank and this is Learning and Technology with Frank. I have to get a logo or something that I can spin around and have some sort of exciting opening to the show. So today I'm excited because we're going to take a look at data architectures. This is something that has actually been the subject of the past couple of weeks in the program that I teach, my full-time job. So we've been looking at data architectures in a little bit more detail during that time period than we will look at here. But I thought it'd be nice for those of you that are my students in that class. This is a good recap for you. And for those of you that are not students in my class, welcome to my YouTube channel where I share a bunch of things on learning and technology and using technology to learn and teach better. In this case, we're going to look at data architectures a little bit more specifically, so it's a little bit more subject focused, but I think it might be interesting for those of you that are interested in data. And the reason I wanted to do this is we've seen a lot of changes in the world of data architectures over the years, and I wanted to talk a little bit about what some of those changes look like and where you might fit into working with tools that are part of those data architectures. Because I will say there's not one all-reaching, all-knowing, perfect data architecture. There are architectures that are designed for enterprise. There are data architectures that are designed to be in an on-premise data center. There are data architectures for small businesses that don't need to be as complex as some of the other ones. But I thought we would go in and we'd have a little bit of a look there. So let's take a look here. I've got some whiteboard slides prepared for you here, so I'll go through. So with data architectures, we're going to look at data architectures sort of over time, how they've evolved, and sort of what they look like here. So we'll see if we can grab this screen here and move this over. If not, we'll just use our mouse. Okay, so grab the mouse over here and we'll just drag this over. Okay, so when we talk about sort of the history of data architectures, what does it look like in the past? So the idea behind a data architecture is ultimately what we want to do is we want to take data from a source or multiple sources and we want to move it or we want to present it to an audience in a way that helps them make data-driven decisions. And this is nothing particularly new. This is something that's been around for a very long time, but it's evolved over time. We've got more robust tools to do this, but I don't want the tools to confuse the process. That would be kind of a challenge or something that we most likely want to try to avoid. So in the very earliest days working with data, we would normally just build our reporting structure into the applications we built. So this goes all the way back to the days when we were working on mainframe systems or when we were working on a monolithic program that would run in an organization. And what we would do is, as part of the process of developing the application, we would actually build reporting capabilities into that application. So the application would have a submenu in there that would say reports, and you would go in there and you'd run the A, B, C, whatever report was sort of designed for that application to run. And that obviously has some value to it, but it was also very restrictive because if that report wasn't built into the application, then you didn't get that report. Now what you could do is you could bring the application developer back and you could say, hey, could you build a report that gives me this, this, and this piece of data? And the application developer would be like, I would love to do that. And then there would be a development project and you'd obviously pay the associated costs with that. But that's the simple genesis of everything that we actually even do today. We have some sort of digital processing that's occurring. So we have some sort of digital processing that's occurring here. And there's logic built into the application. Now in today's world, this application will have a data store. Back in the days of, I feel like an old guy, back in the days of, but it still is the same architecture. We would have a data store that was either a file storage or as time went on, we actually had a database storage in there. So you'd have some sort of data store that this system would feed from. And this continues to this day. If you look at something like your phone, if you have a mobile phone, when you're working with any application or app that sits on your phone, all of the apps that sit on your phone will have a place where they store the data that's generated by that app. Now, it just so happens that with most apps on your phone, that's going to be in today's world transferred out to a cloud or a third-party data collector. And there's a lot of conversations we could have around that. But the whole idea here, though, is that this app here has a data store of some sort, and we have some way of viewing that data in a way that's important to us. A report in today's world with the apps that might come across as an app interface or even as a web interface. And that's kind of where we sat with a lot of this type of, initial architecture when it came to working with data. But then what's happened after that is, we started saying to ourselves, well, what if I want to create my own report? What if I want to create my own custom report that the functionality of this application does not have this report built into it? So you'd have all of the reports that were built into the application you created, but you could use a tool, and a very common one that was out there for many years, still is out there, SAP has this, was Crystal Reports. So you would install Crystal Reports onto a computer, or you would install Crystal Reports, wherever you're going to do the workstation. You would connect Crystal Reports to the application, and then you would pull, and if that application had a data store that, again, was either a database data store or even a file data store, however that application was storing the data, you could connect Crystal Reports to that data store, and then you could create customized reports by pulling all of that data into a customized report that you generated with Crystal Reports. And you can comment, so if you want to comment, you can only comment from LinkedIn or from YouTube. If you're on Facebook watching this, then the comments are disabled. It just doesn't work with Facebook. But feel free to comment if any of this is something that you're familiar with from back in the day. And I do remember, as an application developer, that we would actually go and purchase Crystal Reports, and then that was actually built into our integrated development environment. Either it was built into the IDEs, it was built into the integrated development environment, or it was an add-on into those development environments where we would say, I am a logic programmer, I am not a report writer, so we would use Crystal Reports as the tool that we could use in order to generate both the system reports or the application reports, and then we could also expose that to a customer or to ourselves as a tool for generating any additional reporting requirements that was of interest to the customer wanting to make decisions. This gave us some flexibility because now we didn't have just, this app does this report. We could now go back and we could say, let's customize some of the reports. So an example of that might be, let's say that this application was a property management system for a hotel. That's something that I'm familiar with. And let's say one of the reports that was built into that was a custom report for, it was, how many rooms are occupied, how many rooms are vacant. We'll call it the rooms report. You would think that if I was building an application to manage a property at a hotel, I would have a rooms report. And you would be correct, I would have that rooms report. But let's say I wanted to create a custom report that maybe had something along the lines of specific types of rooms, and it just wasn't built into the application. I could then use Crystal Reports, and I could use that to build that custom report. So where are we going with all this? Well, this is kind of, how the evolution of business intelligence sort of came to be. And then what we did is after that, right, we started looking at, okay, now that we've got these, reports that are in there, some tools came out, some desktop tools came out that were kind of interesting, and these were called spreadsheets. So spreadsheets would be something like VisiCalc, something like Lotus 123, something like Microsoft Excel, which we're all quite familiar with. And we, again, within our applications here, we would still have the custom reports that were built into the applications. So these are built into the applications, still the same as always. But now we maybe had a more formal type of data store, like a database. Again, this could actually even be file storage. So if this application generates its data and just stores it in a file of some sort, comma-separated values, flat files, tab-separated values, carriage return values, what we could do is we could take one of the spreadsheet programs that were out there, and we could actually connect into either the database or connect into that flat file. and then we could represent the data in a format, and we could actually perform calculations on that data without having to perform the calculations back at the source. This is a blessing and a curse. One is we don't have to worry about getting access to the source once we have the file, or once we've pulled the data into, and I'll just use the term Excel spreadsheet for now, although I'm much more familiar, well, I'm familiar with Excel now, but back in my days, it was Lotus 1-2-3 was all the rage. VisiCalc, it's out there, but I never really used it that much. But Lotus 1-2-3 and Excel were ones that I've used extensively. And with Lotus 1-2-3, I do remember we would create the spreadsheets, and we would sometimes actually, you would even have a human would read the elements off of this report here and actually rekey the information into Lotus 1-2-3 or Excel. And let me know if you've ever been in that situation where you've gotten people that have had to come in and rekey the information in there. That's always been a huge hassle if that's ever been the case. But we would populate these spreadsheets either through manual entry, through a data import entry, or through a rekeying entry. So there's many ways to get the data into the spreadsheets. Now, when I had just one major application that I ran my business on, and this tended to be the financial applications, so this tended to be my accounting system that I would, and with the accounting system, sometimes the logic would lock different elements of the data, so I would actually rekey data so that I could perform what-if analysis or different types of calculations on there in order to understand the financial picture of my organization a little bit more. So that was the world of spreadsheets. And the challenge that we had with the world of spreadsheets is it did lead to a whole bunch of different islands of data. Because what ended up happening, and in this little, in this diagram here, I'm just showing you Excel. And sometimes the term is Excel hell, because now all of a sudden I had all of these different islands of data, and we had different owners of the different Excel spreadsheets. So now I have all of these different owners of these different Excel spreadsheets, and a lot of times those owners of the different Excel spreadsheets would actually act as gatekeepers into the information that I wanted from these systems. So I might have multiple systems now. So I might have multiple systems. I have an accounting system. I have an HR system. I have a production system, a customer database. And I want to be able to get some sort of functional visibility onto those data sets. And so if there's built-in reports, I'm all happy. If there's not built-in reports, either through a data import situation or a rekey situation, I put it into an Excel spreadsheet. But then we have Bob. I spelt it backwards, but we have Bob here, and Bob is in charge of the rooms spreadsheet, and only Bob knows the calculations that went into the rooms spreadsheet, but I'm making mission critical decisions on that spreadsheet, which is great for Bob because that's called job security. So Bob has a lot of job security because Bob's the only one that really understands how this spreadsheet works. And this led to this whole scenario where we have islands of data. And we're going to come back to this because there is a danger that if we don't architect our business intelligence architectures correctly, we could end up back in this situation. Now, when I had an application that gave me reports, if I was happy, I was happy. If I had an application that gave me reports and I needed to customize them through something like Crystal Reports or something, well, then I could do that as well. If it was something where I had islands of data and I all of a sudden wind up with a whole bunch of customized reports, a whole bunch of built-in reports, and a whole bunch of Excel spreadsheets, I'm starting to fragment my data. And this becomes a huge problem, especially as we get more data sets in here that I'm pulling from. And we're going to see later on when we get into a more formalized business architecture that, we needed to solve this problem. And speaking of that formalized architecture, so if I just move over here, one of the earliest formalized architectures, or one of the better well-known formalized business intelligence architectures, is the Kimball methodology. And with the Kimball methodology, this particular methodology, very famous, this is attributed to Ralph Kimball. So this is not anything that I've come up with. This is Ralph Kimball. He's written several books. I highly recommend them. They're fantastic books. And these became the foundation for a lot of business intelligence and data warehousing projects. And when we talk about a warehouse, what is a warehouse? A warehouse is the consolidation of multiple items into one location. So an Amazon warehouse has all these Amazon items in one location. A data warehouse has all of this data into one location. And Kimball wasn't the only one. There's Inman as well. And Inman has the concept of something called the corporate information factory. Now, the idea behind these architectures is that if we have a whole bunch of disparate data sources all over the place, we want to bring them all together, because really the power of datafying an organization isn't taking your accounting system and making a Excel spreadsheet, or later on we'll see a dashboard of your accounting system. That may have some value, but the real utility of data, the real value of data, is when we take that stewardship approach and say, let's look at all the data within the organization, and let's look at things like my customer database. Let's combine my customer database with my production database, with my sales database, with my accounting database, and maybe with an Excel spreadsheet where I've manually input customer scoring or customer satisfaction surveys. These are all the things that we can do to generate the data. So when we look at the Kimball methodology, it's really more of a data-centric project where we gather business requirements around our data. And then there are really 3 tracks that make up working with the Kimball methodology. And we're going to concentrate just on the center track. On the top track here, what we're looking at is my hardware and my infrastructure that I'm going to utilize in order to make a data project work. So this would be the building of my infrastructure in a data center. This would be my servers, my storage, things like making sure I have adequate storage, that I can get good speed to the storage, building the appropriate servers, building fault tolerance, building redundancy backup. So this becomes a huge infrastructure push in order to build that architecture design in order to house the various different things that I have for data. At the very bottom of this architecture, we have application development. So these are the applications that we would have to create in order to present that data. Now, we could use off-the-shelf applications. So we could use something like Microsoft Excel. We could use things like Microsoft Reporting Services. But this has increased over time. So we now have a whole bunch of commercial off-the-shelf applications. We don't have to custom build those like we did in the old days. We also have, in terms of hardware, we can either go and do something like an appliance. This is a little bit older though, but we have something called data warehousing appliances, where we could approach a company and purchase a pre-built infrastructure set, whether it's a set of plans using their hardware or whether they will actually come in and build that hardware out for us at a cost. Then we would have this. But this has increasingly become something that we're seeing very much moved into a cloud infrastructure. So, and I'll talk about cloud infrastructure in a bit, but what we'll do is we'll use an external data center as opposed to building our own internal data center. If we have the capacity and if we have the extra hardware, if we've built a data center that has elasticity to it, so maybe I've already virtualized my data center so that I can do things like allocate resources throughout my organization for the regular infrastructure stuff that I'm doing. Well, a lot of people are going to the cloud on this, but we could theoretically push a BI solution into our existing data center. I'm generally not going to have an application developer come in and build a custom presentation tool when I can just get one off the shelf. But there may be cases where I have some very highly customized things. What we're going to do instead, and the main goal of business intelligence today, would be really the data track. So this center stream represents the data track, and underneath the data track, what we're going to do is we're going to actually aggregate our data. We're going to utilize a process called ETL, extract, transform, load. Sometimes it's ELT, extract, load, transform. And this is where I'm talking about the Kimball methodology. We'll see there's other methodologies as well. But we'll actually extract and bring that data into a consolidated location. We will then cleanse that data in terms of ensuring that the data is clean, deduplicated, that we've gone through and we've made sure that that data conforms, to what we're wanting to make decisions with. If we have data conflict, so if I have two systems that say, different answers to the same question, I can reconcile that conflict. So for example, if my inventory system and my sales system are out of sync, that, traditionally we would do an inventory in order to do that. But what we would do is we would need to bring those into sync. Because obviously we can't say I've got 10 items in the warehouse, pardon the pun, and I've got, accounting 8 of those are sold. Maybe the accounting is that I have to put 2 of those to shrinkage, that they've been stolen or lost or damaged or whatever the case may be. But once we've got this data stream in place, then what we can do is deploy that out for the decision making. And then in the Kimball methodology, we maintain the solution and we grow the solution over time. Deployment here really could be reports. So we might generate reports here, or we might generate dashboards here, or we might generate some sort of decision-making tool in there. And this was, for a very long time, the key methodology that was used for data warehousing in an enterprise type of environment for many years. And it evolved. It evolved, like I said, the technical architecture evolved to externalize that to the cloud. The application architecture was externalized by using off-the-shelf like Power BI, report writing tools, Excel, and all those tools. If you're ever interested, there's a fantastic, although it's a little bit of an older video, it's a TED Talk by a fellow named Hans Rosling, and he wrote he did a video called The Best Statistics You've Ever Seen. And in The Best Statistics You've Ever Seen, he talks a lot about a project that they did. And if you look at this architecture while you're watching that video, you'll understand that in his case, he had to get the hardware. In his case, he had to have his grad students write the software. And in his case, even getting the data was a bit of a challenge. So we evolved, right? So we've evolved now where we've gone from, just included in the application. I'll just move this over a little bit. It was included in the application. We built it to building custom reports using tools like Crystal Reports, to using things like spreadsheets for a desktop business analysis, to running into the problem of islands of data, to a Kimball or an Inman methodology, which is really a formalized data methodology. And the way that looks sort of when we take out the hardware and the application layers here, really what we're looking at is we're looking at multiple data sources. So I'm taking multiple data sources here, and even though I've represented it as applications with data stores, these could also be, flat files. These could be web files. These could be IoT devices. We have a whole variety of data sources. We will use this ETL, which could also be the ELT process. I just refer to it as data movement process. And then what we would do is we turn that transactional data into an analytical data set. This would either be a tabular model. This would be first a multi-dimensional model would be the earliest type. So we'd have multi-dimensional model. We would have a tabular model. And we can even use a pivot table model using a tool such as Microsoft SQL Server. And if you're using the Microsoft stack, and most of the times I do articulate these things using the Microsoft stack, the data source here for a lot of Microsoft solutions is SQL Server, or it could be Access, right? If we're using an Access server, it could even be an Excel spreadsheet. So we could have a source spreadsheet of Excel, or it could be, a Oracle server, whatever it may be. And then the ETL process uses SQL Server Integration Services. To bring it into a model, we use SQL Server Analysis Services. And then to present it, we could use SQL Server Reporting Services, which allows me to create those formalized paginated reports. I could use Excel, so I could put that data into an Excel spreadsheet, except now it's not just ad hoc data in there, and it's not rekeyed data. I'm actually pulling from a clean data source, what we sometimes refer to as a single version of the truth. I could build reports off it. And then back in the day, we used to have something called Office Performance Point Server, and it was a web interface. So this was built on top of SharePoint. So we would have a SharePoint server infrastructure, and then with the SharePoint server infrastructure, what we would do is we'd be able to build data visualizations. But what ended up happening in the world of Microsoft, and I am articulating this on the Microsoft stack, be aware that Amazon Web Services has similar tools, especially when we get into the cloud. They don't do on-prem. Google Web Services has the web version. IBM has both on-prem and web version tools. Oracle has these tools. There are a lot of players in this space. I'm just using Microsoft because they do have what's referred to by the Gartner Group as a completeness of vision as well as an ability to execute. So when I go in here, if I scroll back here and I'll just pop over here, what would happen here is tools came out, newer tools came out for working with the data. And so same sort of architecture, so same sort of Kimball methodology or Inman methodology, but what we have here is we would have some specialized tools that came out to replace things like Performance Point Server. So we would still have our formal architecture here, but all of a sudden we started getting these really powerful desktop tools like Tableau and like Power BI. So that's the icon for Power BI. So we would get these tools, and these tools here were sort of roughly kind of visualization tools. So their predominant focus when they at least first came out was to allow me to visualize data sets in a more robust way. In fact, Power BI version 1, I sometimes joke around, call it version 1, was really just some add-ons into Excel. So you had Power Map, Power Query, Power Map, Power Query. I'm losing sight of the different powers that we had. But we had a whole bunch of Power plugins. So I'll just call them the Power. And that was kind of Power BI version 1. And then what ended up happening is it became its own standalone product. And what happened is some of the functionality that we used to have here in the data process, some of that ETL stuff, some of that OLAP stuff that we did, this functionality was built into the tool. So now I could do direct pulls directly from data sources, and it could be multiple data sources as well. I could pull from those data sources directly into these tools. And that's great, right? Now all of a sudden I don't have to build a big formal business intelligence architecture, especially if I had to do with the hardware, had to do application stuff plus the data set. All of a sudden, I'm in a great shape because I can just take Tableau and I can just take Power BI and I can connect to these data sources. And they even became fairly mature, and they said, we're even going to have, shared resources. We're going to have, if Bob goes in, Bob who used to own this spreadsheet, if Bob goes in and creates a KPI, we'll store that in a Tableau server. We'll store that in a Power BI environment, and then rather than everybody having to go ask Bob, how do I calculate the KPI? That's part of my business analysis. We know how the KPI is used, and I will just go in and use that KPI. So that was sort of the rise of the specialized data applications. And to some extent, this is a lot of what's happening in today's world. A lot of people right now, they're not building out these formal business intelligence architectures for sometimes really good reasons. One, they may be a small business. They may only have one or maybe two data sources. And building out a formalized ETL or data orchestration and data analytic aggregation could be both time consuming as well as expensive based upon the value of the resources building these and based upon the value of the equipment and services required to do that. They're saying, I'm just going to go and buy Tableau, I'm just going to go and buy Power BI, and I'm going to connect those to the data sources and extract value. So we kind of get a schism that happens here where, doing it sort of this way up top here is more of an enterprise, right? It's an enterprise kind of scenario. And down here is more a small, medium-sized business scenario. Now, I don't think that those need to be separated as much. There are architectures that will allow me to get the best of the enterprise tools onto the desktop and the best of the desktop tools being used in the enterprise. But rather than do formal orchestration and analytical aggregation, I can actually just take these tools and I can connect them directly to the data sources. In fact, the marketing behind some of these tools is, don't worry about your data, we'll just use our tool to go and discover all that data and you don't have to worry about it. The question is, will it discover it well? Will it aggregate it? Will it protect it? Will it create one version of the truth? And the jury's out on that. Well, I don't think the jury's really too far out on that. The answer generally is it does not do that, right? We run into problems, right? So what ends up happening is we start building out, so that's kind of the difference between a desktop, small, medium-sized business, and an enterprise type of architecture built on traditional business intelligence architectures like the Kimball and the Inman methodology. But those have evolved as well because we have this thing called the cloud. The thing with a business intelligence workload is that it generally does not require full-time dedicated resource. It's very bursty, right? So what happens is we do a huge amount of aggregation and then we just consume the results of the aggregation. Do a bunch of work, consume the results of the work. So what happens, and you can check out another one of my videos as well on careers in data, where I talk about being a DBA, being a data engineer, being a data analyst, being a data scientist. Each of those functions within an organization has its own purpose and the way that they work with data. If I'm doing data analysis, generally what happens is I'm really concerned about the end point here. I want to use desktop tools, Tableau, Power BI, and I'm just switching to Power BI, but be aware that this could be any of the vendors that offer this. I'm agnostic in this regard, but I just want to use Microsoft to articulate. So I could have Power BI. So here I have a user, a data analyst, and they're using Power BI in order to analyze a data set. But hold on, what's that data set? And they might be using tools such as statistical tools like R, which you can get for Power BI. They might be using tools like Python in order to manipulate that data to get certain visualizations out of it. That's also part of Power BI. They might be using tools within Power BI like DAX queries. So there's a whole bunch of analytical functionality that's built into Power BI. There's also a whole bunch of reporting functionality that's built into Power BI, including paginated reports, which we used to have to use Crystal reports, or we used to have to use SQL Server reporting services to do, or some other report generating tool. But now Power BI has reporting in there. And of course, we can create visualizations such as a dashboard. And here, what I'm doing with the cloud architecture is I could have sources of data which are in the cloud. Very common. Again, if I'm using my cell phone and somebody gives me a free product, right? And they say, hey, this is a great product. What you can do is as you walk around, you can take pictures of things and it will tell you the history of it. So I'm walking around, downtown Washington, D.C. I see something, I click it, it sends my photo up into the cloud. It recognizes what that object was and then downloads the history of it and maybe a few little videos about things that have happened there, right? That's not a bad app. If anybody uses that app, please credit me in that, and more importantly, send money. But anyways, so that's a little recognizer app. I'm sure it's already been invented. And that little recognizer, and you might say, well, what a great little app. But here's what's really happening. It's doing that for you, but it's also taking your location, and it's taking your name, and it's taking the time of day. It's gathering a whole bunch of sensor information, and it's storing that into a cloud-based system. This could be something that is done on a commercial basis, like I've just described, or this could be something that is done on a company basis. So it could be that instead of me being a consumer that's doing this, it could be me as a driver for Uber, or it could be me as doing a commercial application. The point being is that that data is stored in the cloud. So I have all that data stored in the cloud, and we have huge data stores that are in the cloud that can become sources, both destination for collection as well as sources for business intelligence. I could have applications with their data stores that are running on-prem, and it could be that I actually push those data sets into the cloud. It could be that I have IoT devices that are transmitting to and from the cloud, security cameras, control systems, all of those types of things. The point is I have a very rich data environment, and when people talk about, the world of data, it's a critical skill, this is what they're talking about. We are generating and consuming massive amounts of data. But what we need to do from a business intelligence standpoint is we need to aggregate that data by bringing that in through some sort of orchestration mechanism. Again, using Microsoft as an example, I might use Azure Data Factory. I might use an IoT Event Hub as well. And so I might collect IoT events into an event hub and then use Azure Data Factory to orchestrate the movement of all this data. Very similar, right, to ETL, to ELT, whatever you want to call it. Data movement, data orchestration. And a lot of times that will go into a data store. So I'll pull this data in, clean it, transform it, conform it, and put it into a data store. And that there's multiple different types of data stores that we have in Azure. Again, this is a live stream that I'll do for about an hour or so here, but be aware that obviously there's a lot more to it. You can take a 4-month program with me if you want, where I teach. Anyway, so we have this entire aggregation of data that occurs, and then maybe what I'm going to do is do some OLAP or some analysis on there. In the world of Microsoft, maybe I'll do some sort of Synapse analytics on there, where I'll do some pre-aggregation of the data. So I pre-aggregate the data. I've sorted and cleaned the data. I move it into Synapse. I might just put it into a different type of storage and then do things like machine learning on here. So different types of artificial intelligence. This is where I could do things like learn from this data. But then at the end of the day, I'm going to have a desktop system, and that desktop system is going to be sitting, on my desk, and it could be mobile, whatever, but I'm going to consume that data, and I'm going to make business-based decisions based upon that nice, clean, quality, aggregated data that I got through this cloud architecture instead of an on-prem, right? And there's lots of considerations around that. This is just to show you that the cloud architectures do exist. More to the point, I can scale these architectures on an as-needed basis. So I could choose to have different schedules of when I pull and aggregate that data. I could choose to say, I want to look at things day to day. I could do real-time streaming analytics. So I could stream data directly into a data store and look and see what's happening right now. IoT is a great example of that. So I have little circuit boards, right? So I'll use that a lot of times in order to pull into an IoT hub real-time data. There's no sense having a fire alarm that told you there was a fire last night. You need to know that there's a fire right now. So that's real-time stream analytics. So there's an example of the evolution into that cloud environment. So then we can run into some problems. This goes back, if we're not using the cloud environment, we can run into some problems. What about those that don't want to build a cloud environment? They just want to continue using tools like Tableau or Power BI. They want to continue to use those tools in order to connect into data sources. We run into the same problem that we ran into with Excel. We run into islands of dashboards. That's that's a term that I just kind of made up. Islands of information or islands of data has been around for a long time. So I call this islands of dashboards. And this is a concern because it's very expedient for a lot of departments to say, look, I am the inventory department, and I'm not getting very good business analysis. I'm not getting very good project management, but I want to get visual insight into my data. My data is here, and my data is here. So I'm going to go and pull that data into my dashboard. I'm going to pull that data into my dashboard, and you get an inventory dashboard. And then somebody else is going to come along and say, okay, I'm the HR department, and I'm going to pull my data from here, and I'm going to pull my data from where else are they getting it from? From here, I'm going to pull that and create an HR dashboard. So now I have all of these dashboards which are aimed at job function or aimed at individual departments, and what I lose from that is overall visualization on my organization's data as a whole. I now have islands of dashboards. And generally speaking, you'll see this in a lot of organizations. In addition to this, you'll still see a bunch of Excel in here. And that's a data mess. That's a real non-architected data mess, and something that we probably want to try to avoid, but we haven't been able to avoid, because I see a lot of folks that are actually building dashboards for organizations. If I'm a small business, right? So if I'm a small business where I have, 1 or 2 applications with a data source, and I just want to get some nice visualization, that's a very small visualization. You can just do your work in the tool. You can pull from the data source there. And if you have 2 data sources, no problem. And if you have 3, no problem. And 4 and 5, and at what point do you have a problem? And the question is, you need to be aware that all of a sudden as those data sources start multiplying, we start getting data conflicts, or we lose the ability to get a holistic view of what our data is like in an organization, and instead we get a sliver view or a keyhole view of just the data that we've consumed within the tool. But there is some good news. And the good news with this is that we've now evolved cloud architectures to accommodate some of the best of the cloud, which is that elasticity, the ability to grow as we need to. We've taken the best of the cloud in terms of not having to make the hardware investment. We can actually consume hardware, rent the hardware if you would. We've got all of the data collection that's occurring in each of those areas. That's not going anywhere. In fact, that's just increasing. We have great orchestration tools to pull those data sources into a consolidated data source. Stream analytics, time-bound analytics, where maybe every day I'm looking at sales for the previous day. Maybe I'm going, day by day, quarter by quarter, whatever the case may be, so I can still do my aggregated data warehouses. But instead of pulling the data directly to a desktop, what we're doing instead is using tools like Power BI Premium or Tableau Server. And we're building the analytical capability here. And that's the role of a data engineer. A data engineer will use these architectures, and they will build an aggregated, centralized repository of quality information that incorporates all of the data sources an organization has. And then these folks here will be data consumers. And the data consumers may take different forms. The data consumer may be an analyst. But you're not going to get just a pure data analyst. Well, you do today, but I think that's probably going to change in the future. That's just my 2 cents worth. No guarantees on that. But I think what we're going to have is a financial data analyst. We're going to have an HR data analyst. We're going to have an enterprise or process data analyst, or even a business analyst data analyst. What would that be? BADA. We have BADAs out there. Business analyst, data analyst as a job function and a role. So, of all the 85% of the jobs that are going away in the next 7 years, as they say, these roles will evolve. And now what these folks will be doing is they will not be working so much with the preparation of the data. What they'll be doing is they may conform it to a purpose. So they may take it, but we will have these clean repositories of data, either through a data warehouse. So this one here is Synapse as an example. And then we would have something like Power BI Premium. And Power BI Premium would allow us to create a central repository of analyzed, consolidated enterprise information across multiple data sources. So we've seen that, there's been a lot of evolution when it comes to data. And the reality of this is that we're not going to find one monolithic architecture that everybody is using. There are still companies out there that are using the reports that come built in with the applications they have. There are companies out there that are still doing an on-prem, Kimball methodology in order to build out a data solution. There are companies out there that sadly are still trapped with islands of data in our aforementioned Excel hell, right? They're trapped using Excel for everything, and they're not getting the value of consolidated data, right? So that's a good example of some of the different architectures in there. Now I'm just having a quick look, and it's a little bit Sunday night is when I'm trying to do these. I did do a live stream last Sunday as well, but the audio was just absolutely horrible, so I didn't even really post that on YouTube. Hopefully nobody's commented about any issues with the audio here, so I'm going to assume it's okay. So this presentation will be available after the live stream. So if you are watching this after the live stream has already happened, feel free to put comments down below. What are your thoughts on the architecture? What type of business intelligence architectures have you seen that maybe I didn't capture in this little history lesson that we have, or overview lesson? And what I'm going to encourage you to do is think about if you're going to be working in the field of data, be able to recognize what's being used within an organization and ask yourself, how can we get to a more cloud-based solution if that's the direction you want to go? Or how can we get to a more consolidated desktop solution like Power BI Premium or Tableau? You can also use Tableau servers and other products out there as well. Or do we have the capacity where we do want to build an on-prem solution and we want to use our existing data center? There is a fair amount from what I'm seeing, people talking to me, of migration. So we see folks that are migrating from one to another. Hopefully they're not migrating. This is the worst migration in the whole world. If you're going from islands of data to islands of dashboards. I'm not saying that it doesn't happen, but that's the one you have to watch for. If we're just trading one fragmented data environment for another prettier fragmented data environment, I'm not so sure that's a great idea. But comment down below, let me know what you think, and I'll do some more of this type of live stream if it's of interest. So we'll make sure that we do that. So thank you so much for those of you that joined me this evening. For those of you joining me after this evening, comment down below. And Sunday nights, I'm going to try to do live streams every Sunday night at around 6 p.m., 6:05. So there'll be different topics. Some will relate to how we use technology to teach and learn better. Some will be deep dives into a specific technology, such as virtualization, cloud computers, or data science, or data, shouldn't say data science, data topics around not so much administration, but more data engineering, data analysis, and maybe a little bit of data science, and then artificial intelligence, IoT, lots of topics. So let me know topics that you like, and we'll see you in the next live stream. Thank you so much for joining me for this one, and we'll see you next time. Frank out. Take care, everyone.